So I'm looking at it. This is a top-down view of a disk platter. You know, spinning disks. I know we don't use those anymore. We use solid state, but let's pretend we do. So in the olden days, then, when we had these stackable disks, they were divided like this, where let's see, one of these concentric circles was known as a track, and then a wedge of pi was known as a sector, or actually, sector. Anyway, probably getting my terms all messed up, but anyway, there's a concept of tracks and sectors. So we would go to the very first track on the first disk, first sector, and we would write this special MBR record. And that MBR record would just has information on it that tells us how the disk was laid out. Remember, it's using this scheme. So it tells us how the disk was laid out. Where's the first primary partition? Where's the first bootable block that I need to go to in order to load the operating system? That's all the MBR was. And if you broke your MBR, your system wouldn't boot up because it wouldn't know how to do that. So I think that deserves mention. And yes, these are old, these are legacy ways of doing things, but they're still very, very commonly supported on current hardware. And probably at some point in the next year or two in this class, I will move over and talk about that one a little bit, and probably leave that legacy one for my file systems class, but not today. Yeah, to see if we are in fact using the MBR partitioning scheme, we can use a command such as sudo parted -l, sudo parted -l, and right here, oh, I couldn't see it. Oh, I am not using DOS. This is on my office machine. I'm using GPT, so I'm using a different partition table, but you can see my partitions here. I'm using 1, 2, and 3. The same, you can still refer to them like /dev, SDA1, dev SDA2, that sort of thing. Anyway. Okay. And it's easier for us in this class to at least talk about partitioning using this method, so that's what I'm going to do. So on our assignment, what we need to do is we're going to create several partitions, format them, mount them to our file system, and then exercise those file systems a little bit. So let's see how we would do that right here. Let's start with that. Okay, so this is one set of screenshots that you cannot follow exactly. I am giving you just an example of how to use these different commands and how to connect them to our file system. And we did some file system stuff in IT-3100, a little bit, right? So it's not like it's brand new, but you're going to do it a little bit more depth. Okay, so the mount command will show us what partitions are mounted, what file system type they are, and where they are mounted. So if I just execute the mount command by itself, we should see, and let's check. So I'm going to go into my maybe NS1. How about FS? So, yeah, by default, on our systems, we're probably going to have something like dev SDA1 that's mounted on the root, that's our root file system. That says the first partition of my first SCSI or SATA disk. And if you guys were to look at that on your VM, you'd probably see something like that as well. Now, there's a lot of other stuff here. There's a lot of system, what do you call it, runtime mounts. So these are special mounts that we don't worry about. This is actually the only, on my disk, you can see right here, that's the only one that's actually connected back to my disk. A lot of these are created by the kernel when our system boots up. And then I have a lot of other ones, because I've already done the assignment. I have whatever, all these other partitions that I've connected to my system, to my machine as well. Okay, so, and once again, like here on my screenshots, I've got SDA1 that shows up, and I have SDA5 that's mounted at /home CIT user Joe's files, or dev SDA2, which is mounted on /var. So mount command shows us what file systems are mounted. We can also do maybe an ls-l on /dev sd whatever to see what partitions our system has detected. So you can see there's 7 different partitions there on my first SCSI disk. fdisk command -l will show us our partitions again. So we should be able to see, yeah, 7 partition. And the partition table keeps track of what block this partition starts at and where it ends. And it tells you what kind of partition it is over here. Okay. So I already have a few partitions on my system. CFDisk. CFDisk is the easiest, and there's other ways of doing this, so if you guys like to use other tools, that's fine, but I use CFDisk to manipulate or add new partitions. So you do sudo cfdisk /dev sda for our first SATA disk that we're going to partition or add partitions to. And you can see that mine, I already had a bunch. I had 1, 2, 3, 4, 5, 6, 7. SDA1 and 2, they were ext4 format. SDA 6 and 7, they were ext3, or what? One of them was ext3. Yeah. And then I have free space. So what does free space mean? Unallocated. I haven't created any partitions. We can't save any data there until I partition it and format it. You also know the swap space. Did we talk about swap space? When our RAM gets overflowed, then we can stick things in our swap, which is just a special partition that we can go quickly and access and retrieve stuff from. So that's what the screen looks like. It gives us our overall size of the disk, so 17 gigs, whatever, how many sectors we have per track, so forth and so on. Now, this might be a little out of order. Let me skip that screen. I don't know why I jumped over it. Screens out of order. Okay, well, I think I missed capturing. I did it, don't worry, I did it again on my next set of screenshots. But first thing I did is I went down to free space and I hit new. The menu option down here at the bottom changes to new, and I created a new partition, logical, and a certain size. And I'll show on the next screen the part that I missed. But here I can specify what type of file system's on that partition. I typed 83, it's a Linux partition. And it really doesn't matter here what you choose. This is legacy stuff that we don't even really look at anymore. But to pass the auto grader, you should pay attention and make sure you choose what I tell you to on this one. Though in fact, in the real world, it doesn't matter what you choose. Okay, so between this screen and this one, at SDA 7, I created another partition, SDA 8. And it's a Linux, it was 500 meg in size. And then I arrowed over to write. Are you sure you want to write these changes to the MBR or the partition table? Yes. So I type yes. Now if you delete partitions here, what's going to happen?
Is it gone?
Yeah, what if I delete SDA1?
It's not going to boot?
It's not going to boot. That's where I installed my system to. This is after, I'm using CFDisk after system installation, right? So be careful of that. If you delete swap, then swap won't work anymore either, so you might break your system.
It'll run good until you max out the RAM and then it'll crash.
Yeah. So then I hit quit, and now I went to fdisk -L again to show my partitions. Great. I'm just showing you some examples of how to use the commands. That shows my SDA8, blah, blah, blah. Okay, and the next thing is after I've created the partition, I have to put a file system on it. Now putting a file system on it is formatting it. We create the inodes on it, we create the super blocks, whatever we have to lay out the system.